Hey everybody, here's a review for our first polar coordinate assessment. We're going to have one on graphs a little bit later on this week, but for right now, I'm going to try to make this a little bit crisper. Here's the 4 different things that we're going to talk about. Plotting points and plotting polar points. You're probably going to get about 3 to 4 of these, and you're going to plot them on one polar coordinate system. So you'll have like A, B, C, and D, and you'll have to be able to plot them. You're going to have negative r's, so you have negative r's, negative thetas, so you need to know how to plot negative r's, negative thetas. Converting polar and rectangular coordinates, how to set them up, algebraically, and calculator. No one ever said I could spell good. Multiple representation of polar coordinates and distance between polar coordinates, and I'll put LOS right there because it's not LOS, LOC. Early morning, you know how it goes. Alright. Law of cosines. Alright, so plotting points. Here's the first thing. This is the type of graph that you'll get. Now remember, that's 0, 90 degrees, 180 degrees, 270 degrees. Or that's pi over 2, pi, 3 pi over 2. And that would be 2 pi. This is 15 degrees, which is pi over 12. So all of these are multiples of pi's over 12. So if you get like 2 comma 3 pi over 4, for example. Now what you can do is you can say, alright, 2 is going to be the second ring, because the R value here is always going to be what ring are you at. Now, if you're still uncomfortable with what these are, you can go to degrees. But an easy way to do this also is to say, alright, I'm going to take 3 pi over 4. What do I have to multiply the 4 by to get to 12? And that answer's 3. So I'm going to multiply by 3 over 3. Multiplying by 1 makes no difference. It's 9 pi over 12. So that basically means that you can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this right here is 9 pi over 12, which is equal to 3 pi over 4. And I know I'm at 2, so I'm on this line. There's 1, there's 2. There's the point. And if that's point A, put point A right there. So that's a nice, easy way to go about doing that. We've been doing a lot of those, and like I said, you'll get A, B, C, and D. If you have, for example, let's say negative 405 degrees. Well, take this, negative 405 degrees, add 360 to it, and you're going to get a negative 45 degrees. So that tells me that we still have to go negative 45 degrees, or 45 degrees in the negative direction. That's 15, 30, that's negative 45 degrees, and I need 4. So 1, 2, 3, 4. If that's point B, there you go. So just be careful about where you're putting your points and where everything else is. Now, polar coordinates. So 2 polar coordinates. Polar coordinate is still rectangular. If you have a polar coordinate r theta, this is going to convert to r times the cosine theta, r times the sine theta. And you'll just have to make sure that you're in the right spot. Should be good to go. The calculator, since we're in polar coordinates, you're going to hit book. And then what you want to do after you hit book, which is right here, hit P, which is right there, and then you can go P arrow RX, P arrow RY, and that'll get you an approximation. Now, if we're going to go rectangular, go A, that's B. Rectangular to polar, then you have your X, your Y, and we want to make this into R theta. R is going to be equal to the square root of X squared plus Y squared. Because essentially what we want to do is, if that's R, there's Y, there's X, we have a right triangle. We use the Pythagorean theorem to get R. Now theta is going to be equal to the inverse tangent of Y over X. Then put this angle in the proper quadrant. Always pay attention to the to where your X and your Y are as well. So once you know what quadrant you're in, once you know your theta, you're going to be able to put the angle in as you need, as you see fit. Now, your calculator is going to be rectangular, arrow, P theta, rectangular, arrow, PR. And then you just type in XY, XY, and it should give you your answers. So that's your calculator, but I will ask you to set everything up so you can work through there. Now, multiple representations of a point. This would be, for example, I might give you the point 360 degrees. And find 3 different polar coordinates. So let's first off plot 360. That's 15, 30, 45, there's 60 degrees. And I know I'm at 3, so I'm at 1, 2, 3. There's my angle. And I know, let's get a different color here. Let's go with red. I know that's 60 degrees. And that's 270 minus 30 degrees. That's 240 degrees. So I can say, and go all the way around to here and get to 240 degrees. But I'm going to plot on the other side, so I have to make R negative, because that would be on the negative side. Now we start talking about negative angles. Because I have my 3, I have my negative 3. If I want a negative angle, I would go this way, and this angle would be, that's negative 90 180, 270. That's negative 300. So I got negative 300, and I have a 3. But I can also go negative to here. 90, that's negative 120. So I can say it'll be negative 120 degrees and negative 3, because I plotted on the opposite side. So what you want to do is just figure out different ways of getting to the different angles. And last, but certainly not least, is distance between two polar coordinates. I'll pick a couple. Let's say you have 3, 120 degrees, and then you have 5, let's go 60 degrees. So now, what we want to do is we want to plot these points. 3, 120, 90, there's 120. We get 1, 2, 3. And I will draw that in right there. 5, and then 60 degrees, 5, 10, 15. Or 15, 30, so there's 60 degrees. 1, 2, 3, 4, 5. And I want to get this distance right here, my x value, right there. Now I know that is 60 degrees. I know that guy's 120, so that guy is 60 degrees. So now what I've done is, to get 180 degrees, this guy has to be 60 degrees here. Now, the law of cosines is going to say, alright, well, if this is R1, theta 1, and this is R2, theta 2, my x, that's a 3, that's a 5, my x is going to be equal to, I take the 3 squared, plus 5 squared, minus 2 times 3 times 5 times the cosine of 60 degrees. So x would be equal to 9 plus 15 minus 630 times the cosine of 60 degrees. Actually, that's 25. Remember, early in the morning. So that's 34 minus 30 times the cosine of 60 degrees. At this point, I'm going to use a calculator because I know the cosine is 60. Well, actually, the cosine of 60 is going to be 1/2. So it should be 15. So, but easiest way, 34 minus 30 times the cosine of 60, and then remember to always put the degrees in there just in case someone's been messing with your calculator. And we want to keep things in degrees because most of my classes are geometry and they need degrees, or else they'll freak out. And you get 4.589 as your x value. And that's how you get your distance. Now, if you wanted to figure out what is going to go into there, you can go 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 60 degrees, and you get 19. That's the square root of 19. That ended up being exactly what I thought. Cosine was 1/2. Half of that is 15. 34 minus 15 is 19. Square root of 19. Bam, exactly what we got. So that is, sorry about that, kind of went crazy there. That is your review. That's what we're going to be doing. You're not going to have a ton, but it'll be there.